afternoon, good evening, or good morning from wherever you're joining us from today in the world. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor Sydney live stream event. Today you'll see on the screen with me I have Renee Noble, and she is our regional cloud advocate at Microsoft, and we will be doing our episode 2 of What in the Wordle series, which is a bit of a tongue tire. So firstly, a bit of background on Renee. So Renee is a self-proclaimed Jane of all trades. She's worked in government doing ML and Python backend, full stack in the ed tech startup sector, and dabbles with the embedded tech. In her spare time, she also leads the Girls Programming Network for women and girls to realize their potential as techies. She's also started to help bring exciting coding opportunities to kids and teachers. And so after that, a bit of background on Renee. Now we'll just a bit of housekeeping. So we'll be speaking for about 40 minutes with 10 minutes for questions. However, do speak to us throughout in the comments section. Ask as many questions as you like, and we'll try and answer them as we go or at the end. We'll also share with you a link to our feedback survey with the event code. So if you have time to fill that out, that would be awesome. And if there's anything you'd like to reference back from today's session, you can do so on our YouTube channel, which we'll also share with you the link for later on in the session. And all the resources from today that Renee will be speaking to you about and guiding you through will be available in the chat section. But without further ado, I'll hand the floor over to Renee to begin. So thanks so much, Renee, and over to you.
Thank you so much, Sarah. Excited to be here for the second episode of What in the Wordle. We're talking about first words today. I think we might actually be here for the full hour, Sarah, so sorry if you had plans for the last 10 minutes. But do ask questions throughout. We'll be covering a few different things, so yeah, I can see your comments and I'll answer them as we go. So yeah, please let me know. And also let me know where you're joining us from in the world today. And also, very importantly, what is your favorite Wordle first word? So yeah, the first word dilemma. I myself like to do just a different random word, whatever I'm vibing that day. You know, it typically has probably an R, an S, or a T, a couple of vowels, but sometimes not. But some people are very particular about their first words. There's a whole series of different things all over the internet, articles, videos, memes about first words. And here we're going to talk today about what's your best first word. Thinking about the data behind choosing a first word, the advantages of some aspects or others, and really what helps you move on to your second word or finish off the game of Wordle. So it really depends on what you want. So we're going to look at an approach to make your own Wordle scoring system, basically. And we're going to look at things like vowels. We're going to look at consonants, letter placement, and all kinds of things. So we're going to start off with vowels and consonants and finding words that have a lot of vowels in them, well and voweled words, I'm going to call them. And sononant consonants is something I've learned about since Wordle has become a thing, which are they're kinds of letters that go well next to each other. They make particular sounds in your mouth, and most words need to have some of them in them. So they're the other, less appreciated category of sounds, I'm going to say, that we've got to look into making useful starting words. We're also going to look at popular letters. What are the most popular letters in 5-letter words? And do they have specific places? Do letters have favorite places that they live in words? And is it more advantageous to put something in one of those spots? We'll use all these bits of information to make a customized scoring system where you can balance it out for, you think vowels are more important, or you think consonants are, or it's all about letter placement for you. And we're going to look at how this is going to set us up for the second guess of the turn. And have we boxed ourselves in by using all the good letters in the first guess, or have we set ourselves up so there's an equally great guess for our second guess as well? Whether you like to play on hard mode and you want to prepare for a dud first guess where you get nothing right, or you like to do 2 different completely disjoint guesses for the first and second guess, that's what we're going to prepare for there. So today we're going to be doing a bunch of data analytics, I'm going to call it. I'm not going to call it data science for this episode. We're not really setting a hypothesis. We're more just doing an investigation, sussing out what's in the data. And then we're going to look more at data science and experiments and what we can learn from those experiments in later weeks. We're going to be doing all this in Python and we're going to be using Jupyter Notebooks and MatPlotLib. So Jupyter Notebooks is a super useful tool, and MatPlotLib is going to let us do graphing all of the data that we look through. So first up, vowels versus consonants. Some people are obsessed with saying adieu or audio. Other people might be doing perky, march, crank, or maybe you sit somewhere in between. I know that's kind of where I tend to go, but not always. So today we're going to start off by looking at vowels and consonants and how we can utilize the knowledge of what is a good vowel or good consonant combination to have. So before I get started, this is the Jupyter Notebook I have set up in advance. I'm using Visual Studio Code, VS Code today, and it's got a really great Jupyter Notebook editor that you can just, as you can see, I've set up all these headings, and I can actually write Python in these cells here, and you can just execute it in the middle of your program, and you can just see I've printed hello. And I've got all this extra context of my notebook around it. So yeah, we're going to be using this today. It's a really useful tool. It also spits our graphs that we make up with MatPlotLib right into here as well. So to make one of these, I'll just quickly show you. We would click make a new file, and we might say test, and we could give it the file extension IPYNB. And you might be like, what is that file extension? It doesn't make any sense. The way to remember it is Jupyter Notebooks used to be called IPython Notebooks. So IPy Notebook is what you want there. And then you can start by adding code and markdown cells. So markdown, you can add your headings and you can tick them and they become all big if you do them correctly. You write your markdown like that. And you can write in your code here in your Python cells. So that's a really useful tool. I actually hadn't used Jupyter Notebooks for a while. Of course, you've got to set your interpreter. I hadn't used them for a while because they used to be a bit, hard to use because you had to have a special interpreter or use it in the web browser. And it was just not as easy as it is now just to run it in Visual Studio Code. So yeah, that's what I'm using and I'm loving it. It's really useful. And I think it's going to be really great for going through our process because I've got all these cool headings, and when you pull the repo yourself, you can have all that context as well. So to get started, we're going to need to open up all of the words that we have available for choosing our first word. So I've copied in the same file that we used last week, which is all of our allowed words, borrowed from the internet. It has, and I've combined all of the allowed words as well as all of the ones that could possibly be the correct answer. Some of the sites keep them disjoint, so you need to get the words that could be correct and the other ones that it allows you to guess and put in there and join them together. And that's what we did last week in the first episode. We used that same list. So that's in there, in the file there, and now we're going to start by getting all of that out. So the same as we did last week to open it up, we're going to say, the file is called official. No, it's called allowed words. .txt. Make sure that's actually the same one. This has got 112,000 lines. How many lines do we have here? Great. Okay, that looks the same to me. I think I've just called it something differently than I did in my practice run. Okay, so good to know. Always double check your data sources. So we're going to open the file as F. That's what we're just going to, a typical way of calling your file handle. And then we're just going to say all words equals f.read them all and split them based on where the new lines are.
Renee, sorry to interrupt. We've just had somebody in the chat section ask if you can paste the repo so they can pull it. Please.
Certainly. So if you jump to, Sarah, could you paste the link to my website, the landing page for it? Right there on there will be the link to
Absolutely.
The repo, just under the description of the text. I can even show you where you'd find that. So yes, this one, here we go, just under this picture. you get see the series code on GitHub. Thank you very much, Mikara. Okay. Sarah says she likes using a different word every day, but you'd like to include 2 vowels. So that's very much on my vibe as well. Okay. So back to where we were. So we're getting all of our words. And then I'm just going to print out the first 50 of them just so we can see what we're working with here. So all words, and then you can split a list in Python. So you could put something on either side, like 5 to 50, which you go 5 to the 49th ones. But I want 0, which you can just leave blank, to here. And I'm going to print out how many words there are, just so we know what we got. Okay, cool. And that looks right. We've got a bunch of words that start with A. We've got 12,000 and something, things there. So we have all the words loaded up. Okay, so next up, we are going to actually look at what's inside of those words. So I've got my section here, which I've dedicated to finding the most en-vowel-ed words. And today I'm going to use something called Default Dictionary, which is super useful. It's probably my favorite thing to import in Python. So it's in the collections library, and I'm going to import default dict one word. And what this is normally you'd have a dictionary and you'd say, A is the name of my dictionary. And then I'd have to, if I wanted to add, so for this dictionary, I want to always be adding something. Basically, I want for a word, I want to add, every time I see a vowel in it, I'm going to add one to the score. So at the end of it, I want it to look like the word cat would have 1 vowel, and the word hello would have 2 vowels. And the best way to do this is by going through each letter in the word and adding 1 every time you see a vowel. But the problem is the first time you see a vowel, then you have to be like, oh, well, this word doesn't exist in the dictionary yet, so I'd have to add it first. Instead of just being like, what we would do is we might be like cat, look up cat, and there'd just be plus 1 to what's there. This is a sneaky way of saying add 1 to the existing value. But because it's not there, it would freak out and be like, that's not a value I know how to look up. So by using default dictionary, we can say, hey, if I ever want to look up a value and then add to that value, in this instance, we're going to have a default value. Then in this instance, we could look up cat and be like, oh, cool, let's just add 1 to 0, which is going to be our default. So what we're going to do is start our default dictionary. I'm going to call it vowel count. But Sarah saying hi to Bibi is my cat's name after we've talked all about cats here. And here we go. We're going to use a default dict, and we have to pass it a function. So I'm going to pass it int. And int is a function that returns an integer. The default integer is 0. But you could set this up to be any default thing you wanted. If you wanted a default list, you could write list and it would just put an empty list in there. Or you could write your own function to give you back a specific thing. So next up, we've got our default dictionary. Now we want to go through all the words. So we're going to say for word in all words. So give us 1 word at a time. And then for each letter in the vowels, we're going to go through the vowels and say, hey, if this is in the word, then give us a point for that word. And the reason we're going through the letters in the vowels rather than the letters in the word is because it might have double, like 2 occurrences of the same letter. So we might have books, and then we don't necessarily want to give it 2 points because it's got 2 O's because it's not giving us a new vowel. That's just my opinion. As I said, this is kind of made up in how you want to do it. And data analytics and data science, we're going to see later, you can just fudge it and really make it do what you want. And that's kind of a lesson to know, because if you don't pay attention to what you're doing, you kind of just end up with mush that you've created and it looks like numbers, so it looks real. So this is the mush we're creating today, which is fine because this is for Wordle and that's just fun. But be careful when you're doing real data analytics. So we're going to say if the letter in word, then we're going to say vowel count, and the word we're adding them for, we're going to say you get another point because you've got another vowel, and then that's the way to get all of the vowel scores. And then I want to sort this based on the vowels that we have. So the thing is that we now have a dictionary of things. So we might have A is just a pretend dictionary. A is 1. B is 11. V is 12. Let's say 2. And J, just some random keys we're putting in here, is 4. So now we want to make sure these things stay together because we need to know what they are. But we also want to sort it based on this value. And if you sort something based on just if you give it the default sorting mechanism, it's going to base it on the key, which is the first one here, not the value. So I'm just going to do a little demo on sorting, how we can sort something based on the tuple and the second item in the tuple. So firstly, let's say we'll give this dictionary in. We're going to call it mydict. And then we're just going to print, mydict.items. So for sure, this is going to throw up a little error for us first. Well, not an error, but oh no, it does show us our things. So it gives us a dict items object, and that's not something you're allowed to sort because it's not a list. So I'm actually going to say listify my dictionary items. So when we print this out, now looks like a list, not a different kind of object. Okay, so now I want to sort this. So let's start by doing sorted. If I do this, we now have A, B, J, V, the correct order of the letters, but our number values are not in order. So to make this be different, you can give it a key. So I'm actually going to split this out so it doesn't look too crazy. So we're going to put new list. I'm going to print, bigger again, new list out here. And we're going to make our new list. It's going to be a sorted version of our list. Okay, so we're going to give it a key. And the key is, we give it a function again, lambda. We're going to give it a lambda function, which if you haven't used a lambda function, it's just like a function you can do on the spot and then it kind of just gets deleted. You don't have to define it elsewhere. You can just write it in the line. And what I'm doing here is saying our function needs one thing, and this one thing is going to be the list item that it's sorting, which is going to be one of these tuples. So that's going to be X. And then what's going to happen next is we need to say what part of this value is the part we're sorting it on. I'm going to say X, the the first or the 1th item of X. So the default is X0, which is that first thing in the list, and we want to give it the next one along. And that's going to be what we sort on. So I'm sure I'm missing a bracket or have an extra one somewhere. So we're going to do this. So now it goes 1, 4, 11, 12, which is great. A, J, B, B. They're now out of order, which is what we want. And everyone is with their buddy, their key value pair. So one last thing is we can actually reverse this as well because we want the thing with the biggest score first. So we can just write reverse is true. And that's going to give us 12, 11, 4, 1. So that's what we're going to use in our code as well. So after we've done all of that maths, we're going to use vowel count here. And now we can print out, we're not going to print the whole thing, we're just going to print the top 20. Print sorted vowels count. Okay, we're going to print that. We're going to get 0 to 20 items. Let's go. Nope. What have we done? That should be int, which is our default value, not 0, which we got put in as our demo. Okay, here we go. The things that have 4 vowels are these ones. Some of these I've heard of. A lot of them I haven't, but that's okay. Maybe you have, and then you feel like that's the word for you if you're a vowel person. But also, yeah, those are our most vowel-y words, and then we can see we've got the ones that are worth 3 vowels. They're coming up. So we can do the same thing for consonants for our next set of things. So our sonorant consonants is what we're doing next. And I'm going to paste this here first. And we're going to only do a slight change. So we're going to call this cons count, firstly. Okay. And then we need to change this part. But our sonorant consonants are actually not all just single letter things. So the sonorant consonants, which I thought I'd put in here somewhere. I'm going to copy them across so you can all see them. These. So we've got Y, W, L, R, M, N, and ng, ng. So we actually have this double letter one, which means we can't just do the same thing as we did here because we want to not have N and G separate. We want them as one unit. So we're going to make this our list of everything. So we're going to say, here are the things that are allowed now for our consonant check. Yeah, these are special kinds of sounds in the English language. Okay, so now we can do the same thing that we had done before. And we will see what we've got. I've printed the wrong thing or done something not quite right. Let's find out. So we've got collections, we've got const count. For each thing in the words, we're checking in the letters, we're adding to const count. We're sorting vowel count. There we go. Let's go again. Here we go. Some really weird looking consonant-y words. So yeah, trying to find anything that looks in here like a word I would actually use. Rawly, that's kind of something I might say. Wormy, newly, there we go. Manly, there's some words that sound more familiar. Yeah, so we've got 2 different options now. So maybe like, I love the vowels, they're for me, I'm sold. Or I love the consonants, perfect. I want it right, omri. Every day. That's what I'm going to use every day. But maybe you're like, I need something in the middle. This isn't my style. So what we're going to do is actually, as we build up our different techniques, we're going to make a little scoring system. So we're going to make a little function because we're going to need to use this later, not just this one time. So I'm going to start again by importing collections and default dict. Just so we have it, it's imported above, but just so it's in this little blob in case we want to run it independently at a different time. I'm going to make a score. I'm in the wrong version of my notes. 1 second. Let me double check. Where is our combining thing? Okay, here we go. So I'm going to make our score. Okay. And then we're going to give it a word. So we've already got these 2 bits of code. So I'm just going to grab vowel count. Bring them down here so we can have them together. And our consonant count. Okay, so we've got those 2 bits of logic on hand. So we've already got these dictionaries, so we don't really need to have this part here, but we do want to say, we get rid of those parts. Let's go back a step. Well, you don't need that. Okay, we have done those bits of logic above, and how the IPython notebooks work is that those variables continue to exist. So we can access the same stuff that we've used up there. Let's just start with what we're doing. So if we have so we're going to go for each of the words. We want to, for each word, we're deciding, maybe, I'm not sure how much time we're going to have, so maybe let's just do a quick, for all of the words we want to say in all words, for word and word lists, all words. Then we're going to do, firstly, I don't want anything that has a double duplicate, so they're out. So what I'm going to do is I'm going to turn my word, which is a string, into a list, and then I'm going to turn that into a set. So a set is the difference between, A, B, C, D is a list, and then you'd have a set with A, B, C, because you don't get any duplicates. So if they're the same length, then I know that they're, there's no duplicate. So I'm going to say if len word the same as that, then we're going to, so I'm going to pop it back in our function because it lets us do some handy stuff. So I'm going to say, I'm going to call this, we might want to run this on a different set of words later. So I'm going to say, we're going to give it word selection. I'm going to call it for possibilities. Yeah, okay. This is going to be good. Cool. Cool, we've got our options there. And then we're going to say, okay, if this happens, then we want to, we're going to give it a really bad score, I reckon. We're going to say, okay, start by saying our score count equals default dict. It's going to start off as 0. So we've done, okay, we're going to start with a default dict. Anytime you want to add a word, it's going to be like, great, I'm going to add on to the score that I've already seen for this word, which may or may not exist, but doesn't matter. If it doesn't exist, it's going to be 0. We're going to start off by setting anything that has a duplicate letter into a really bad score. So we're going to say that score count word is just like minus a huge number. So we're going to say like minus 100. So it's never going to end up in our best things because I don't ever use duplicate letters for my first word. You might. You don't have to have this part in your own scoring function. So now we've got that. We can say also we want for each letter in the set list word again. So we're going to do this. Actually, no, we don't need to do that for this part. We're going to say for each letter in what we had above, we're going to score it if it gets, if it has a vowel in it. So I'm going to just grab some code, which we used earlier. Each letter, we're going to add to the score. If letter in word, just the code we had above. Okay, and score, count, word, just like we did in above. And we're going to give it like an amount. So maybe we're not going to always give it 1 like we did when we counted them up. We're like, maybe a vowel's only worth 0.5, or maybe it's worth 10 because we really like them. So I'm going to go with 0.5 now. So then we're going to have the same thing for our consonants. Cool. So I'm going to grab our consonant list so I don't have to type all those quotes out again. Okay. Great. Now we might say, oh yeah, consonants are more or less important to us. So maybe we're going to say 0.4 for consonants. That's how much we care about them. So then we can give it a run. We better give it something to test with. So I'm going to say, we're going to call this function. Oh, we better return the score actually. Return score count. Okay. So at the end we say, okay, we calculated all the scores based on their voweliness and their consonantiness, and also that they don't have any of these duplicate letters because we don't want them. And then we're going to give back all of the scores, and then I'm going to store them in score scores. So we're going to store them. And we're going to score possibilities, and we're going to give it the word selection, which is just all words. We might want to run it again later on a smaller set of words. That's a hint for what's coming up. So we've got the scores, and then we're going to use, again, that sorting code to get the best items for us. So I'm just going to grab that code again, so we don't have to write this out everywhere. Okay, there we go. So we're going to use this code again, and we're going to print out just the top 20 and see what we get. We get the scores, and now we're going to just do that slice again, order our 20 best scores, and we hope that it all works. Okay, so we're getting a lot of vowels still. What happens if we do like this one is like worth like twice, like 4 times as much as that? Okay, so yeah, we get back to Amri and those again. So let's say the consonants are worth 0.6. Okay, cool. So yeah, let's just set them to be equal for now, I reckon. Right, okay. So we've got some of those consonants and some vowels. So these nice middle words, I would say, they're looking good. So adju's gone. We say adieu to it because we're in the middle ground now. So that's looking good. So let's look at what's the next most important thing for us to do. So we've looked at vowels and consonants, but obviously there's vowels everywhere. So they're really popular. But what if there's other really popular letters? So I'm going to look at how popular different letters are in the alphabet, because maybe they're really useful to have in there and not just vowels and not just those sonant consonants that we've been talking about. So for this one, we're going to tally up how many times each letter appears in all of the words in the whole list, and then we're going to make a graph of it to see what ones are the most popular. So once again, another default dict. I told you I really like them. I'm going to call it total count, and I'm going to set it to be default dict. Once again, int, because we want to start with it being 0. And for word, in all words, that's for fun. You're going to see a lot today. For letter in word, and we just want to add a total count. So if I see an A, I want to add 1 to the A's. If I see a Z, I want to add 1 to the Z. So I'm just doing that for every word in the list, for every letter in each word. So total count letter plus 1. Okay. And once again, we get that sorted list printed out at the end. This only has 26 items, so I'm going to print the whole list, which will be fine. So we can see that E is the favorite by just a slim margin, just by 4 E's in the whole set of 12,000 words. So that's pretty close. Good on you, S, for getting up there as well. And we can see, yeah, the best letters are here. And SOAR, S-O-A-R-E, that's, people are throwing that around as maybe one of the best ones. But, up to you based on that's, hasn't got many sonant consonants in it, so maybe it's not your vibe. We can also clear these output cells based on if we don't want to have them around anymore because they're really long. So let's click clear that because it's in my way. Okay, so Jack, my lovely partner, is in the comments saying that I taught him how to use default dicts and he uses them all the time. It's the best thing. I just have to say, you got to get on these. So now we have that data. We could see it in the format, in the list, but that's not as fun as seeing it in a graph. So we're going to make a graph and it's going to be super chill and easy. So now we need to import MatPlotLib. And the convention is to import it as plot, like plot, because it's just shorter than writing. We need to import pyplot specifically. Pyplot. It's just shorter to write plot instead of pyplot every time. So this is how people do it. And we're going to use the sorted items because this time we're going to say we want them sorted A, B, C, D. So we want the first letter we want the letter rather than the value, just so they turn up in alphabetical order so we can check them out. So we're just going to say sorted and total count. And the items, once again, gives us all those tuples of the key and the value. And then it's just a couple of easy lines to make that into the data that we want. So we're going to have our x-axis, which is the letters, and then we're going to have the values, which are the y-axis. So we have in our data, we'll have, might have A, we could say it's got 5,000, and then we've got B, it's got 3,444. So we want to get all of the A's to be the X values, and we want all the Y's, which are these numbers here, to be our Y values. So we could easily just grab the alphabet and turn it into the A's and B's and C's, and split them out. But we can easily also just grab them from the data we have. That way you can use the same method if you are doing something other than the alphabet. So what I'm going to say, I'm going to do a list comprehension, which we did a bit of last week. And you can just do this with a for loop, looping through each of the tuples and building up a list one item at a time. This is just a tricky way of just doing a for loop in one line when you want to build a list at the end. So I'm going to say, so we're going to get for I in data. So for each item in data, which is our sorted tuples, so A 5,000, B 4,332 or whatever, for each of those pairs, we're going to get just the first value for our X's. And for our Y's, we want just the second value. So it's just really splitting those things up into two. And then super easy line to make our graph, X, Y, and we hit go. And wait just a second. Here we go. There is our beautiful graph of all the letters. So we see S, E, very popular. A, not far behind. R, also very good. O, yeah. I, vowels, winning. So yeah, looking good. T, U, also very popular. So I feel like people have a general vibe of that in their life of like, what are the popular letters? But it's good to know specifically for 5-letter words, because I think E in this pool of all words is even more popular. You might get a lot of words like executed or exaggerated, and they have a lot of E's. And yes, you get different patterns of words when you allow longer words. So we also want to kind of see how this would play out in our scoring system. So I'm going to use like how many E's in the whole thing have, how many words in the whole set of things have an E. So we're going to say we want to just get the length of all the words, and then we can kind of see what the highest score might be as a percentage of all of the words that we have. So I'm going to print out the total count of how many E's, because we know that's the most popular one, divided by the total words. So what's the percentage of words that have E in them? And we can see that I've done it incorrectly. Total count, what are you? Where is our total count? Okay. Interesting. Total count was a dictionary. Somewhere along the line, I have overwritten it potentially. So, got our items. So that worked. Interesting. We don't want the total count. I've overridden it here. Total words, let's call that. Oops. If you control click on things, it will take you to the definition of that thing. So where are we? Lost us in our code. We've written so much code already. Okay, here we go. Letter frequencies. We're back on track. Done it again. Don't do that, Renee. Okay. Total words. We've done it without control clicking on it. Total. Okay, no, it is, because this is the thing that we're scripting. Total count. Where have we last dealt with new total count? Because it was just a dictionary. We've got the spinning wheel of problems. Okay. Let's print total count here. Okay, so we've got everything there. Okay, so at some point, let's run it here. Same line, just to check where on earth everything's gone wrong. That's still there. Total count. Okay, maybe it's just because we'd already overridden it. So yes, if you run these cells out of order, then things get a bit messed up. So that's why you probably wouldn't use an IPython notebook for anything like ideation and practicing and experimentation. And it's good to have all of this stuff self-contained in a cell. So we can see that 51% of words in this set of 500 words have an E in it. So let's say, the top score, there's that 51%. So maybe we'll go back up to where we've got our bringing it all together. I'm actually going to take this down with us as we go because we're going to be adding to this as we go along. Whoop. Bring it all together. Come on down. So yeah, you can just reorder all these bits, which is super convenient if you want to reorder your code and have it in different areas. And we're going to chuck it below our letter frequency in here. Okay, so let's grab that same code out that we have here. Well, we have this dictionary now. So what we want to add to our scoring system is that we want to give things that have that letter, like the letter E in it or something, a higher count value when we are scoring them for our system. But once again, we don't want to give them extra points for having, duplicate letters. If something had like 3 E's, like my name, for instance, could be like very well rated because, E's are likely to be in the word, but that's probably not useful. So we're going to say that the letter in set list, so turning that list of words into ones that are unique, we're going to give it a score. And the highest score is going to be the most popular letter. So we're going to add to that score that we've been working on based on each letter in that list. So for E, you're going to get that 0.51. If you had Z, maybe you get 0.05 or something. We have to look at the data. So we can grab the code for that, which looks like total count we calculated earlier, and we have that dictionary on file of all those scores available, and then we're going to give it the letter and then divide by the total number of words, which I'm going to grab that total words just so it's on hand in this function as well. So I just put that at the top. We're going to play with that total words a little bit later. Okay, so now we can run this function again, and it does not like it if you add a dictionary to a float. That's very reasonable of it. Total. Let's just rename this to num words. That'll be a better name for it. Always telling students about having good variable names. And, then you mess it up yourself and then you overwrite your own variables. So we better run this one again because I think I've overridden it and it's going to be angry. So let's try now. Have the same problem. Okay, what have we done? The score count is float, I hope. Unless have we used score count anywhere else? I hope not. Total count. That's okay. We've done it. That seems fine. Who here is a default dictionary? Score count. Of course. We need to give it a word that's trying to add on to the whole dictionary. Here we go. Okay. Now we're talking about things that have really popular letters. Okay. But the thing is, we've also accounted for vowels, and we've got things that have the sonant and consonant. So maybe we're like, actually, because they're getting kind of double points for being a vowel and for being, high on that graph that we just made. So maybe we only want to have this at being like 0.2, and this can be 0.3, as you wish. So you can make that up as you would like to. Okay, so we've got, learn, that's a good, see, some of these words, they're looking like things that I could actually remember what they actually are. So maybe these are good. But also I reckon that it's probably really important where things sit in a word, because we could have all kinds of different words that have the same letters in them, like a rose, saw, eros, as we saw. Saw was high on the list before. We just look at those graphs of where the positions are. But what one would be better? Is the position of the letters important? So we've got this graph. You can see these are our favorite letters. But what if we split it up into a different kind of graph? So we want to actually show what positions each letter is in. So we could say, here is the distribution of A's. Most of the A's are maybe potentially in spot 3. Obviously, this is a graph that I drew by hand. And then second spot might be 1. And maybe you would favor putting your A in the first spot. And then do that for each letter. But we're also going to take a look at the data to find out for each spot what the spot's favorite letter is. So we can say, oh, maybe we should be putting this P, let's pretend it is, in this spot. So we're going to work on how to make these two different graphs. And the way to do this is actually by making, in the case of the first one, 5 plots. So you make the data a list that's 26 items long, one for each letter, and then we're going to put in one at a time to make the 5 plots like that. Obviously, the other one is 26 plots of smaller length, 5 numbers. It's just the same data turned sideways. So in order to do this, we're going to make another default dictionary. Instead of just having A and counting up how many A's total, we're going to count it up for each spot. So we're going to go, okay, this is another A that's in the first spot. We're going to add onto this. So we're going to get started on that. So letter placement. So we start up by doing that default dictionary. When we have the data, we can then make our graphs, both of our different graphs. If you have any questions, just a reminder, you can ask them at any time. So making our graphs. So MatPlotLib, you can really make any graphs that you want. You can make them, fiddle them around to get whatever you want in the end. But yeah, we need the data first. So once again, you're going to get from collections, import default dict. And then we're going to do position count equal to default dict. And once again, we're going to start with an int, which will be 0. Okay, so for each word, we want to get each letter and also the spot that it is in the word, and then going to add it to that default dict. So we're going to start for word in all words. And what we're going to do is another enumerate. So what we did last week as well, we did enumerate. So we can do for I letter and enumerate. Enumerate word. And what this is again is saying, let's get rid of all these crazy red lines. Okay. Is saying, hey, I want to count through the word. I want each letter, but also I want to remember what spot that was in. So that's where the I is. It's just going to be 0, 1, 2, 3, 4 for our counting in this instance. So then now I have all the data I need to put into my default dictionary. I want to say for this spot, maybe it's 4 and the letter A, add 1. Cool. So now we have all of that. We could print it out even. We need to print it if I'm going to print it out. Print position count. Big dict. 0th, first position A's, 736, etc. So we have all of that data, and now we need to turn it into the list that we saw in the slides. So either these long lists, 5 long lists, or 4 or 26 short lists. So that's what we're going to do now. I won't go through this part in as much detail because the MatPlotLib stuff is a bit just finicky and you're just playing around with getting your headings and stuff in the right places. And putting your ticks on the putting your axes bits where you want them. But I will describe what I've done. So let's grab a bit of code. So I'm going to just copy in some code that I'm using. So first up, I'm going to grab this code here. You might want the alphabet at some point in your coding career, and you can just ask Python to give you that. You can say string ASCII lowercase, and you can now have all the lowercase letters, and it's in alphabetical order. So now we have the alphabet available. We're also going to want to import another thing, which I'm going to chuck here. This figure pyplot. We did that above, but yeah, importing figure specifically, we can change the dimensions because, as you saw, some of those graphs are going to be really, really wide. So we're going to want to be able to change the width, which we set with figure. Okay. I'm going to grab some some things that I have set. So this is just how wide I want each of the blocks to be and how big a gap I want between each of our things in here. So this is just this gap in here I've set to be 3. Oop, jumping ahead. Want this. Yeah, okay. So the next thing I'm going to grab for you all. We also have things like how many groups are there? We're going to start out with the one that has 5 groups and then has 26 things, 26 letters in each group. And we're going to start one of those groups. I'm going to say we're going to start the first group at position 1. I just don't want them to be at 0, so they're butted right up against the axes. So I've just said the start is 1, and I'm going to make a list of all the starts for those different groups, just because it's going to be easier to plot all of our data if we know where each of the groups starts. So that's what this is doing. It's saying, hey, make a list by looking at the last. So we start by putting the first thing in the list. And then we say, okay, go through the numbers 1 to the number of groups. In this case, it's 5. So 1, 2, 3, 4 is where we're going to stop. And we've already done the 0th one by putting in start. And look at the last thing that was in the list, which to start off with where we start, which is 1. And then add on the calculated width to get to the next group. So that's going to be how many items are going to be in that group times the width of each item plus a gap to get in between. And it's going to get us this times 26 plus the gap gives us the next starting location. So that's all just a bit finicky. So we're not going to do it in too much detail, but you have the code and a vague explanation of how it works. And when you plot the things, you can kind of see how it plays around with it. We're going to say we want it to be really wide. So it's going to be 25 inches wide. So it's the whole width of my screen, basically. And 6 inches tall. And okay, so we're going to want to grab. So next up is the part where we make the data into the right shape. Okay, some more code. What have we called our position count in this one? I called you position count. Okay, hopefully it figures out that that exists soon. Okay, so what happens is we want to go through each of the group starts. Because we're going to work, when we set up this weird giant graph, we need to tell each bit of data exactly where it wants to stand. So we're going to say, start by jumping here again. We want to say, okay, here is the starting position for each of these ones. That's what this coordinate's going to be. So we need to calculate that coordinate, and then we need to grab the data for that height for the y-axis. And then we're going to plot that one, and then we do the next one. So that's what this is all about, this whole section. So for each of the group starts, so for each group, start by getting the spots for this group. So if you are up to the second item, for instance, we're going to go, okay, where did this group start? We're going to say, grab the width of an item, and then we're going to calculate the size of the group one bit at a time for each item in the group. So yeah, we're going to take each group and say, okay, this is where each part is going along. Okay, then the position count is where we get the Y's. So that's those heights. And we're going to say, okay, we want to get for each spot, for each number in that group. So we've gone 0, 1, 2, 3, 4. We want to get that number and a letter from the alphabet. So it might be how many times does the A appear in the 4th position? We can look that up in position count, which it should know exists. And then we can get, once again, we're doing a list comprehension. So we get that whole list of those things for each letter in the alphabet. So we're going to make a thing that's 26 things long. We're going to make 26 spots for them to go in, and then we're going to plot it. So let's see what happens if we run it. It freaks out because it still doesn't think it knows where that is. I promise you that we made this above. Let's run this one again, just so it knows that they're there. Make sure I haven't spelt something incorrectly. I have spelt something incorrectly, and now it's throughout the whole code. Maybe before we commit to this misspelling, I'll fix them up. That seems like the wise thing to do. Otherwise, sometimes if you have a text editor that auto-completes things for you, you can end up with a whole code base that has something spelt wrong in it, and people won't notice for years. I have actually seen this. Okay, look, we've got our graph now. Okay, so that's looking good. We would like some labels for it, though. So there is some more finicky work to get the label spots as well. So we want it to be A, B, C, D, E, F, G, all the way to Z, and repeat. We can kind of count 0, 1, 2, 3, 4, 5. So we're not going to put those as axes on here because that's, that's just cluttering up our space, which already has a lot of stuff going on. So I'm going to start by getting our label text and our label spots, because we once again need to tell the labels exactly where to go. As I said, you can do anything you want in this, but it's a bit, you can do anything you want because you have so much power, but it also means sometimes you need to do a lot of extra work to make something look good, which we could probably make this in Excel, but it might not handle all our masses of data well. So here we've gone, okay, let's get the spots by calculating where we put all of those bars, and then repeat it 5 times for the alphabet. And yeah, and then that's pretty much what we've done. We can see that S is super duper popular as the last letter. A is really popular here. O is also popular here. So A and E, S and E, probably that's where you want to end. A or O might come next. And yeah, so we've got options. And then of the remaining letters, because we don't want any doubles, then B or C. So we go C or B, and then A or O, and then maybe an R. So we could have cares or cores or bears or boars or tears or tours. Some of these are definitely words. I'm not sure about all of them. So yeah, that's what that looks like. I'll give you the code for the other version of this because it's very much the same, just switching the groups of how it looks. So yeah, we're running out of time because there's just so much data to play with. Okay, so once again, we've got the opposite version of this. We've got each spot for these, and we can see S just loves to be in this last spot. This is useful to look at because we kind of see it from the other perspective, because maybe you're trading off where to put S or where to put T or E if you think it's really important to have one of those in there. So now we have the data for all of that. And let's calculate what's the best way to utilize this data in terms of our scoring system. So we can see that S is the most popular in that spot. So how high is the, how many points is it going to give you if you put something there? So let's see what we can do for that. So we want to grab position count, and we're going to give it, it's in the last spot, so it's 4 and S. And then we want to divide it by num groups. What num groups? Num words is what we called it. I spelt this wrong again, I will correct all these spellings before we put it up on the internet. Where are you, position count? Okay. Look, I don't want to find it again right now, so I'm just going to divide it by all words length, and then we're going to print that out. I think it might print by default. There we go. So we get 0.3. So maybe you think this is really important, and then we're going to add it into our calculator system. Where is our calculator gone? It was after here. Okay. Come on down where we have the rest of this data. And then we'll finish up in just a second if my doc would jump out of the way. Stock is not playing with us well today. I think there might be a button that helps us move this down. Split cells. No, don't do that. Well, no, I have not found the button yet. Come on, scroll on down so we can actually finish. Not quite on time. Never quite on time because there's too much fun Python to do. Oh, goodness. Okay. We're going to, since we're low on time, I'm going to show you one that I prepared earlier. So, combining them all together. So, what we've done, this is the exact same as what we've been doing. I've decided here that maybe this stuff's overrated now because we actually have the exact position counts. It seems so much more valuable than what we've been doing with just, does it have an E in it? Does it have an S in it, or an M or an R, etc.? So we've got more useful data. So I've said that maybe the value that I want is 1.1 times the position score. So points if you have it in the right spot, and some extra points if you have things that have popular letters in them as well. So we can use that to calculate what some of our best words are. So let's just run that one there. See, we get tears, lares, rails, rates, nares. That's the kind of things that we're seeing now. Lots of these airs things again still. And we could, of course, change any of this to be including more vowels. Because, yeah, at the end of the day, you're choosing a first word, so you have a good time choosing your second word. And if you find that if you use all the vowels in the first word, you're unable to choose a second word, then don't use them all up and maybe give it negative points if it has lots of vowels even. So we've done all that, and we've made this into a function here already. And I've added this extra part where you can set the total number of words because I want to talk about going to our second guess. So you might have a dud guess for the first one where it's all wrong, or maybe you like playing so you do cares and you have a completely different disjoint word for the second one, and you want to make sure you have a good second guess and you haven't used up all the useful letters. So we want to run this again, but with the remaining words. So we're going to say we can't use any of the words, letters you used in your first word. What's the best remaining scores, and what is the way you could maximize this joint score? So your first and second guesses, which I think are where you really sink your teeth into Wordle. What's the best combination there? So down here, I've made a way, which we'll do more of next week, of ruling out all the words that have letters that you used already. So eliminating anyone who used the first word. And we're going to call that function again above, and we're going to call it on just the set of words that remains after you've made a guess. So for every first word, check every possible second word, and then eliminate it if it's not allowed. And if it is, score it based on how well it does on the calculator we already wrote. And then compare it. Then we're going to add those together to compare what is the best. The reason we added in this part here, the total words, because you might not want it to be the total words that are remaining, because if you do one word, it eliminates a different selection of words to the other. So it doesn't give us a same base number to compare our scoring systems again. So that's why we've done that. You might also want to not do that if you were doing a different kind of calculation. So in running this, with the system that we set up, we get Laris and Tony are the best combination of first and second words. And then Rails and Tony. Tony's really hidden it up here. Tolls and Rainy. So these are the things that, given the calculation that we've done, it thinks is the best. But also, potentially, you want a completely different calculation for the second word, or different ratings or rankings based on if it's the second word, because firstly, maybe the probability of you getting a lot of letters right in the first word should be considered. And that's just more data science you could add into that calculation. So that's, what we've got for you today. I hope, post in the chat if you've got a new favorite word based on all of this, just while I wrap up with our final slides. So the resources that we have for this course are all available on the landing page for this website, as well as today's code, which I will push shortly once I fix all the spelling mistakes. So grab that from the link. Sarah will post it in the chat for us. It's also up here on the video. There's a bunch of links if you want to learn more about MatPlotLib or Jupyter Notebooks and other things. Microsoft Learn has heaps of different little courses and modules and pathways you can do to learn all that. And you can learn about free trials on Azure if you want one of those. And register for next week, because I hope you come along. So check out what it's about and say yes, you'll be there. So click links, learn stuff. That's where you can do it. Next time we'll be creating a game solver. So it's something that plays the full game of Wordle. Given we've started with the first word and kind of the second one, we'll keep on going. We're going to put it in a Python object, because that's going to help keep track of all the game state, because you need to kind of know what you've done in the previous turns to make your game solver possible. Then the logic of eliminating words can be a little bit tricky. You got to look at all of that game state. And finally, how do you choose different between words that are reasonable? Like, what words are actually ones that are likely to be the answer, because they're all from a curated list of things that people typically know. So that's all I've got for you today. I hope to see you next week.
Thanks, Renee. And thanks to everybody for tuning in. As Renee mentioned, go check out that webpage that's got all the links on it. I did also add them into the comments section whilst Renee was doing her demo. So you can check them out in the comment section or on the website. But I suggest going to the website so you can also register for next week's episode. And also there's a link in there to check out future upcoming Sydney events that are hosted both by Renee and also some other great people out there as well. And we have our survey here with the event code 15619. If you have time to fill that out, that would be great. And if you'd like to reference back today's session, you can do so on our YouTube channel now straight away after you can see the on-demand version. That's all we have time for today. And I guess you've answered everything during your presentation, Renee, so no questions today. Yeah. But we will see you next week for Solve Games, that episode. So have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event.
Thank you, everybody, and I hope you tweet your new favorite first words at me at Noble Renee on Twitter. Bye.
Thanks, Renee. Bye.